This video would be a short introduction to artificial intelligence and machine learning. Let us look into the agenda. We are going to look into what AI is, what is this landscape, some examples, how do you differentiate the different types of AI, and then we will look into some advantages and disadvantages. When it comes to machine learning, again, we'll see what it is, how do we train a model, what are the learning techniques employed there, and the relationships between algorithms and models. So let's look into what is AI. So AI is a branch of computer science that aims to teach machines and systems to perform tasks that typically require human intelligence. These tasks include learning, reasoning, problem solving, perception, language understanding, and decision making. It would encompass the ability to consume vast volumes of data and make informed decisions. In the next slide, we will look into some definitions of AI as perceived in the industry. So, IBM defines it to be a technology that simulates human intelligence. McKinsey says it is the ability of machines to perform cognitive functions generally associated with humans. So, in summary, we can say that AI aims to create machines and systems capable of performing tasks that typically require human intelligence. In the next slide, we will catch a glimpse of the AI landscape. The diagram on the left portrays um, machine learning, deep learning, and generative AI to be subsets of AI. So we have seen what AI is. Let's look into what is machine learning in this slide. So it says machine learning is a subset of AI that enables machines to learn from existing data and improve upon that data to make decisions or predictions. So ML is all about incorporating certain learning techniques and making predictions. Okay. Um, we will look into deep learning and cognitive and generative AI in subsequent videos. But for now, we want to focus on AI and ML. Now let's look into a use case. This is a project at JP Morgan Chase where they automated the document review process of certain contracts. So it developed a AI system known as the contract intelligence system, which employs image recognition to identify different clauses within certain contract types using unsupervised learning. And we will see what is unsupervised learning soon. Now, in the initial implementation in this project, this particular AI system was able to extract approximately 150 features um, from the annual business credit agreements uh, within a matter of seconds, which would otherwise take uh, annually around 360,000 hours. Okay, so this particular system was able to categorize the contracts and retrieve appropriate features that enable them to make better decisions. Okay, now what are the different types of AI? So here we differentiate them at the top level based on its capability and functionality. So from the capability perspective, you define an AI system to be narrow, general, or super AI. When it comes to narrow AI, they are designed and trained on a specific narrow task. Okay. For example, the recommendation engines provided used by Netflix or by the restaurant apps, they fall in that category. General AI are systems which have human intelligence and are able to perform various tasks. Okay, and super AI would be those that surpasses human intelligence. Um, it surpasses humans' capability to solve problems. It would be creative more than human beings. So this typically at this point is a very hypothetical concept, but so far we have seen narrow AI in play. Okay, when it comes to the functionality, the varied functionalities of AI systems, we have reactive machines, which are most basic of AI systems that we see around. An example where they do not store data, they just make decisions based on current context. Okay, like the IBM's Deep Blue chess machine. The other one is limited memory AI, where you keep certain memory from the recent past, um, like self-driven cars. Theory of mind is another functionality wherein it understands human emotions. And self-aware AI is wherein it possesses self-consciousness and awareness. Okay. So these are the two ways you differentiate AI systems. One is based on its capability, and other one is based on its functionality. Okay. So in the next slide, we will look into some advantages and disadvantages. Now, there's a lot more advantages and disadvantages than I have listed here, but we'll just quickly review some of them. Okay. Now, the first advantage is the ability to match subtle patterns that would otherwise be almost impossible by human beings. Okay. And distributed computing power makes this possible, or deep learning enables this to happen. And this the advantage can also be associated with the ability to scale, that is to process thousands of features and make predictions. Coming to the disadvantages, it's AI systems are complex. The complexity can be with respect to data cleaning, selecting the right algorithm, and tuning the model. This requires subject matter expert knowledge, which cannot be understated. Okay. So it's not that we have an AI system and then we don't need any SMEs around. That's why models come built in, right? We buy built-in models, but then we would later on need to retrofit our enterprise private data into those models. Again, we require SMEs for that. Now, looking at the last disadvantage, it relates to data poisoning, which can result in wrong predictions. This can jeopardize not just the AI engagement, but the entire enterprise as well. So, there are some, we need to build guardrails around these disadvantages, but of course, gain from the advantages that AI offers. Okay, so we looked into what AI is, and now let's look into what ML is. Okay, what is machine learning? So let us say we want to predict house prices. Okay, using traditional programming, we we use an algorithm, or we build an algorithm or a logic that would take into considerations the multiple inputs that would determine the price of a house. Now, now this algorithm can get complex for complex scenarios. Okay, let's say we want to predict stock prices. The final stock price can be influenced by hundreds, if not thousands, of various parameters, including natural disasters. So it's virtually impossible for us to design and implement such an algorithm that will be that will predict stock prices to the dot. Now, this problem can be solved by machine learning, which attempts to build an algorithm based on data. So as you see in the figure on the left, the algorithm is an input that goes into the machine that will process the input data and generate output. But if you look at the figure on the right, the algorithm is the outcome of the machine, unlike it being an input in the traditional programming. So we build models based on data. Okay. So that is what is machine learning. And some of the examples that you see here is spam mail identification, predicting how much sales I can make if I invest so much money in advertisements, or market basket analysis. And there are several other use cases that you could think of. Now, how do these machines really learn? How do we build these models? How do we validate these models? That's what we'll see here. Let's say we want to predict house prices. Now, um, when we would do, we would have a master data set of all the houses that has been sold in the last so many years, and we would collect all those details, and with what was the different parameters of these houses, for example, the square space or the location or the number of bedrooms, all those things would be taken into consideration, and we would also have its associated actual house price that it was sold at. Okay, so we got all the features that would determine the house price, and we also got the actual house price, and that is what consolidates our data set. Now we split that into training data set and testing data set. Okay, and the major chunk would be the training data set, which we would feed into our model and ensure that over a period of time the model is tuned accordingly so that it would predict the house price in line with those incoming features. Now, once we have built our model, we want to test it. And at that time, we would feed in the rest of the data, 25% data or 20% data, however you decide. And when we feed this, we would feed it without the actual house price. And then we would compare it, what does the AI system predict and what was the real house price. And that's where we get to know we validate the system. Okay. If there's a big delta between those two, the predicted and the actual, then of course we have to go and rebuild and update the model, else we would be ready to deploy that particular model. So this is how we train a model and test a model before we deploy it. Now, how do these machines learn? What is the art and science behind teaching these machines? That brings us to two popular learning techniques known as supervised learning and unsupervised learning. In supervised learning, algorithms are trained on labeled data, meaning that input data is tagged along with labels. And these labels are used to identify subsequent data inputs. Okay, when it comes to unsupervised, they don't have labeled data. And the system would it works on identifying similar data and puts them into groups. Anyway, we will see more of these subsequently. So here is supervised learning, wherein you see these are the data points. These are different shapes. And along with these data points, we also feed in labels. That means we tell them this shape is a rectangle, this shape is a triangle. Okay, so data and labels are pushed into the model, and we build the model in accordance to this particular input label data. Thereafter, when you test the model, you just send the shapes, you don't send the labels at this point, and the system should be able to predict the appropriate label. So here we use classification algorithm to identify these shapes and tell that this shape is of a triangle and the other one is of a circle. That is to do with supervised learning. Supervised learning also can use regression algorithm to predict a numerical value, as in the case of classification, where we say it falls into this class or other class, whether it's a spam email or a non-spam email. Here, we can predict house price or amount of rainfall that's going to happen tomorrow. So internally there's a mathematical model wherein we have a function of the input which will decide the output. Again, there is a noise or an epsilon that comes into picture based on the context. So that is to do with um, supervised learning. Now, coming to unsupervised learning, no labels are input. The model will have to identify and segregate the input data based on identifying patterns. So they are then accordingly grouped based on similarity. On the left hand side, you see that the data was segregated into three groups. Okay. Now looking at the right, they also use, now this is the clustering algorithm that you see on the left hand side. On the right hand side, they have used an association algorithm wherein they can associate or find relationships among these segregated groups. And that is where your market basket analysis comes into picture, where we see that certain items are linked. Where there's bread, the person is most likely to buy milk as well. So that sort of relationship, and then of course they put those things close by in a shop. So that is to do with unsupervised learning, where we do not feed the system with labeled data, but it is unlabeled data, and the system would segregate based on um, similarity. And then, of course, it can find a relationship, some association among those groups. The third one is known as reinforced learning, where the model learns through rewards and penalties. The agent will take actions, and based on the environment, it will be either rewarded or penalized. And this is best represented by the Bellman equation. At each cell, the computation would decide what is the appropriate step to take. So as this particular robot moves from the lower bottom cell to the rightmost, it has to decide which is the right path to go. Okay. And certain cells has to be avoided. And so it says at this point, it could go this way or this way. That's why you see the value is 0.73. But once it goes here, we know it has to go this particular route. And here at this point, it knows if it goes in this direction, it is going to get the reward. Okay, it is 0.9 here because it has to go one extra cell to go to the reward. Okay. So now the last slide, I want to just talk about algorithms that come into play while you build these models. Now, linear regression is all about predicting numerical values. And you could use linear regression algorithm with a data set of house prices, and that will enable you to predict the prices of the houses based on the features. So there will be n number of parameters or features that would determine the house price. So it is best addressed through a linear regression. Now, when it comes to analyzing medical reports and finding out what treatment is appropriate for a patient, then the decision tree algorithm comes into play, or is a best fit in certain cases, wherein the decision tree algorithm processes this data and creates a model that can classify new patients based on their symptoms. Okay, so anyway, there are a lot more algorithms than linear regression and decision tree, which we'll see subsequently. Okay, so in closing, we saw what AI is. We saw the different types of AI. We saw a use case of AI. We also saw the advantage and disadvantages of AI. And then we saw machine learning is a subset of AI. But then machine learning comes with its own learning techniques, supervised learning and unsupervised learning, and reinforcement learning. And then we saw how we train and test a model. And that's what we covered in this particular video. Subsequently, we will have another video on deep learning and generative AI. Okay, so that we have just covered all these topics. Thank you.